Så, hej och varmt välkomna till HSB Living Labs stora temadag om att bygga hållbart med lera. Vad roligt att ni är här. Lera är ju ett av världens äldsta byggnadsmaterial. Människan har byggt bostäder av lera i tusentals år. Ändå är det här en metod och ett material som vi lite har glömt bort i dagens moderna byggprocess. Men det är kanske dags att plocka upp lera som byggnadsmaterial i lite större skala nu. För det bubblas och det pratas om det här materialet lite överallt just nu. Det är ett hållbart material, det är ett vackert material, det är återbrukbart, det har många fina kvaliteter. Och vi visste kanske inte att intresset för lera var så här stort när vi bjöd in till den här dagen. Men vi har 140 deltagare idag. Vi är ungefär 30 på plats här i HSB Living Lab och vi har över 100 deltagare med oss online. Jätteroligt och helt fantastiskt. Vi visste inte att det digitala intresset var så stort när vi bjöd in till den här dagen. Så ni som är med digitalt, vi ska försöka göra vårt bästa för att ta med er på den här dagen. Både på seminarierna men också in i vårt lerlabb som vi har i rummet här bredvid. Vi ska försöka så att ni får se samma saker som deltagarna här. Och har ni som är med digitalt, om ni har frågor så kan ni ställa dem i chatten. Och så samlar vi ihop frågorna i slutet av varje programpunkt. Men vi som befinner oss här i HSB Living Lab, vi befinner oss i Göteborg på Chalmers campus i ett fantastiskt levande labb. HSB Living Lab är ett världsunikt levande labb och här bor ungefär 40 personer permanent samtidigt som hela huset är ett laboratorium. Här forskar och utvecklar vi framtidens hållbara boende dygnet runt alla dagar om året. Vi tittar på hur man bygger hus på ett mer hållbart sätt. Vi tittar på hur man driftar och förvaltar fastigheter mer hållbart. Och vi tittar också på hur man bor på ett mer hållbart sätt. Och vi har startat över 150 projekt under en 7-årsperiod. Ni är jättevälkomna att läsa mer om oss på vår hemsida. Följa oss på vårt nyhetsbrev eller kanske komma och besöka oss. Ni som inte är här på våra besöksdagar. Men åter till dagens program. Idag är en temadag om lera för vi tänker att det här är ett ämne som många är nyfikna på. En del kan väldigt mycket om det, många kan ganska lite om det. Så genom att samla en rad experter som bjuder på sina erfarenheter och sina kunskaper så hoppas vi att vi tillsammans lär oss mer och snabbare än vi skulle gjort var och en för sig. Och vi tänker också att den här dagen kanske väcker nya frågor. Och ni som är här eller ni som lyssnar, vi är jättesugna på att starta fler projekt tillsammans med er. För det finns fortfarande mycket kvar att utforska kring lera. Så tveka inte att höra av er. Idag har vi 4 programpunkter. Och en del av er har anmält er till allihop och en del bara till några stycken. Och det är helt okej att komma och gå som man vill under den här dagen. Men första programpunkten är Marwa som kommer berätta om vårt projekt tillsammans med HSB och Peab där vi under den här veckan har byggt fasadmoduler i lera med 2 tekniker. De kommer också ta med oss in i labbet och vi kommer få känna och klämma på de olika beståndsdelarna. Sen kommer Asgeir från Earth Lab och ska prata om projektet Recirculate och hur man kan se avfallslera som en resurs. Sen kommer Johan från White. Kommer prata lite om sitt arbete med att standardisera lera och även vilken potential lera har för trästommar. Och sista punkten på dagen då kommer Niklas från Peab ta med oss in i labbet. Han har byggt för första gången i sitt liv faktiskt lerfasadmoduler den här veckan. Han kommer berätta om sina erfarenheter kring själva processen med att bygga med lera. Så jag tycker vi kickar igång. Marwa, välkommen upp.
Good morning, everyone. First, my talk will be in English, so thanks for your understanding for this. Very happy to be here today, especially after a week of excitement working on testing different earth techniques together with my colleagues Nicholas and Rasmus. So we are happy to have you all here today, both physical and online. During the coming few minutes, I will talk a little bit about earth construction in general, and then I will focus on this experimental work that we did together with HSB and Peab. And then I will end a little bit with like what could be kind of reflections for how we could move forward and leave it to my colleagues to continue with their presentations. I'm working as a professor and a docent, both at Aalborg University in Denmark and Malmö University in Sweden. And my expertise is basically in climate responsive and you could say the general umbrella is sustainable architecture and environmental design. So I work a lot with natural materials, especially earth material. I publish a lot on traditional techniques and how we can learn from vernacular traditional architecture, taking lessons for our contemporary and also for our future environmentally friendly practice. In my teaching, I also try to introduce those techniques to my students. So we try to develop several concepts and techniques on how to do this in contemporary practice with all like strict standards and regulations, and at the same time how also to move it forward for even better performance compared to what we have now as standard for energy efficient or for all these kind of green building standards that we have, especially in the Swedish context as well. Yeah, and also, you know, we have a problem that this kind of ways of building is not common in the architecture and engineering practice. So this is also an initiative to try to equip the future generation with this kind of knowledge and experience. So today, as I said, I will talk about three main things. We will discuss together why we are here today and listening and interested in knowing more about earth as a material. I will dig deeper into the experimental work and I will take you on a little tour here in the lab. And then I will summarize with what is next and leave it to my colleagues to continue from there. So let us start with why earth as a construction technique. It's early in the morning and I would like to invite you for a morning exercise. If you just breathe with conscious, like breathe in and breathe out. Only two Swedish words I know, andas in and andas ut. How did you feel about it? Was it difficult to breathe? Did you find scarcity of air around? Or it was in the room normally? If you go out, if you're home and in the car and the bus, whatever, it's natural, right? You breathe in even without thinking. But now when you have your head with conscious thinking of the process, you feel like it's an abundant opportunity having this air around us available wherever we go, right? It's actually the same with earth. It's all over. It's under our feet. Wherever we go, we step on earth. It comes in different forms and different texture and different colors and different properties. And it's a wonderful resource that we can make the best use of with conscious if we know how to use it in the right way. So another awakening morning exercise. How many people do you think live in earth buildings? Anyone had a guess? Yes?
1/4 the earth population.
Okay. Guess?
When I started in this field 20 years ago, the number was 60%.
60%, yeah, good guess. Any more guesses? So also people online can jot down their guesses and then they can know the answer, so they see if they win with us today or not. So it's 1.5 billion on 6 continents live in buildings constructed with raw earth, and 3.5 live both in buildings both with earth and bamboo. Bamboo is also one of the fast-growing material, and it's also easy, flexible material to use. So it's also one of the very popular material as well. So if we look at this map, which is produced by UNESCO, and we can see earth, how is, or like building with earth, how it's situated in different parts of the world. I think you know the Sweden. So we have earth in Sweden because many people doubt still that in Sweden we used to build with earth. Every time I start to speak about earth in Sweden, it's like, no, it's not possible. How is that even true? Like we could build with that. Can't you see the weather here? It's raining and snow. Yes, but I'm not saying that we are going to build with sugar. I'm saying we are going to build with earth, but with a conscious awareness and how we can use this material in the right way. If we talk together about the benefits of working with earth, there are plenty of benefits, and I'm sure Johan will say even more. So I'll just quickly. So the soil is, of course, as I said, locally available. It's local resource. It's 100% biodegradable and possible to recycle. It can be quick and easy to construct with. Nicholas will share more with us at the end and how this can be learned. The know-how can be learned so quickly. It's a non-toxic material, no health hazards. We have been working without face mask or anything. It's not like working with cement or other industrial toxic material. It has high thermal mass and can provide possible passive heating and passive cooling properties, and it's also extremely durable. If I ask you again another question, what would be the building that has to be super secured and super safe when it comes to the construction? Make sure this building is super safe.
A hospital.
Yes, but if safety connected to security.
Nuclear power plant.
Oh, wow. Yes, good read. How about a bank? It's very strict when you get permission. Now this bank is safe to open for public, to keep a lot of money inside. It's very hard to get through all these kind of tests. So it's possible to build a bank. This is from Egypt, a city that had a very distinctive local character using kirshi. It's a technique using salt earth. So it's the clay that is around salty lakes. They use it and they construct with it. So it's a kind of a traditional way. So the mayor or the governor of the city want to keep the character of the city and the town. And even a bank was able to get a license to prove that this walls, the material used in construction, is safe enough to have a bank. And when it comes to, I think we are close to your answer from first question. When it comes to hygiene and safety, the most sophisticated building to get approval for a material that it's safe and hygiene. Lab, right? That's also a good guess. Hospitals, yeah, healthcare places. So here's a proof that it's possible to get approval to construct a hospital from earth technique. This is rammed earth technique. It's from Austria by Martin Rauch. Of course, as you know, it's super hard to get approval for a material. You need to do a lot of tests in order to prove it's antibacterial and there's anti-friction, all these kind of hard, sophisticated tests. How about acoustics? What could be one of those buildings that is very sensitive? Concert hall, music halls, and what else? Cinemas, could be churches, a place where there's singing or performances or music. So this is a cinema house, also by Martin Rauch in Switzerland. There's no insulation, no sound breakers, no any treatment for the walls. It's just pure rammed earth. Here also the Constellation Chapel in Berlin, also by Martin Rauch. So the main structure is earth, also rammed earth. And the quality of sound there is unbelievable when it comes to the quality of no echo and all these important sound quality you need in such spaces and places. Even if it's with curves or if it's sharp edges, still the material can perform well when it comes to vibrations and heavy duty. A building that had a lot of machines in and out and need to be strong, anti-shock. Factory is excellent. Oh, you're awake already. I don't need all these voices. So this is a factory by also Martin Rauch in Switzerland, and this is the Ricola Herb Center. So you can see also how it's very durable when it comes to using also rammed earth for the construction process. A child-friendly material. And what could be a building also that is very sensitive to this. Schools, daycares, kindergartens. So also earth is very child-friendly. It's actually, they love it. They love to touch the walls and they love to interact with it. And you can see like it's definitely fun to be in a place that is also healthy to be in. So those are the future. If we don't care about their health, who else we should care about their health? They breathe and inhale all this toxic coming from all this like carpets treated with chemicals and the walls and with all the textiles because of fire safety and like all these regulations. So all the materials surrounding us, even in this room, there's a lot of like health hazards coming from that. Flexibility. We always say like, we need a material that is flexible. You look at concrete, how wonderful, like we can just make a form and we pour concrete and it comes in curves and like different forms and shapes, and architects keep saying like, yeah, we need a very kind of fertile material that can help us to make our dreams possible. And definitely earth is also material that can come in different forms and different shapes, even curves, smooth curves, sharp edges. So this is another example from Egypt, the same city when I was mentioning this salt clay. So this is an eco lodge or a hotel. It's actually like one night there is over 600 euros to just be there in this place without electricity, without any like mechanical systems for heating and for cooling. And everything is eco-friendly and like natural in this area. So it's really fertile material to use. And it can be possible to tweak it and reform it in different ways and different shapes. A lot of concerns about water resistivity, right? What could be the place that there's plenty of water splashes around? Not a swimming pool, but no. Bathrooms and kitchens, for example. Yeah, we need a lot of like watertight material to use. So how about even a hand wash sink with rammed earth that can be still functional and water resistant. So no more excuses, I think. Not still to trust that the earth is possible to use and can satisfy our needs for different functions and different purposes. I'm sure some of you are doubting about fire. It's still one of the best material at fire resistant. It's actually takes a long time for earth, if it's like raw earth, like the samples you will see in a few minutes, takes long time in order for them to burn. And then after that, we can start talking about like, yeah, fire resistivity because they start to burn from there. So it's really like a long time until they start to react to fire because they burn first. So they are burn bricks, like those bricks we see in our buildings, and then they can start to be exposed to the fire. And then comes the experimental part, where I was asked by HSB first in order to try different ways of using earth for a specific location in Lund for a potential project. And together with Peab, we agreed on doing 2 wall samples, one with rammed earth, because that was a kind of a popular technique that they want to try and test, and another technique that suits the local soil in Lund. And before I say more about this and take you to a little tour in the lab, I want to ask you about your familiarity with different earth techniques. How many earth techniques do you know? And I promise that would be the last question today. 10. Okay. Wow. Great. And how about the rest? You know, 1, 2, 3. How many? None. None. Yeah. So there's over 12 techniques. So you were almost there with your familiarity with all the techniques, and the way they are categorized depends on the amount of water and, of course, the way they are constructed. So if we use small amount of water, like what we did with rammed earth, it's kind of dry or solid. And this is mainly in places where there's scarcity of water, for example. And if we add a little bit of more water, we call it humid. And if it's a little bit more, it's called plastic, because the texture comes more like soft. It's not like plastic, but it's like the plasticity in it. And then if we add even more water, it becomes like liquid. So it's like similar to the cement mortar that we like pour. And those are different techniques that we could choose from. And the choice depends on the type of the soil and its properties. So we choose the technique based on the material, not the other way around. Because otherwise you have to import other material from outside your construction site in order to be able to do this or to apply this technique. So I will only talk in details about only 2 techniques, because those are the ones we applied in this experiment. The first one is the Adobe bricks. So it's raw clay bricks that are sun-dried or air-dried, not fired. So it's similar to the normal conventional process now with constructing bricks. But they are left to dry in a kind of a slow process, not super slow, but like in a calm way without like firing or burning. And it can be dried in the sun. It's called sun-baked, or it can be just left in a place where it's good air and low humidity level, so they can dry evenly and quickly. So you mix the material together, which is the clay from the ground. You add straw. In all times, they add animal manure because it's very good to increase the water resistivity. You can add lime as well if you want to also increase water resistivity, and you mix it together with sand, and then you leave it a little bit to ferment because the straw needs to stay a little bit in the mix. And also straw acts as steel we put in modern construction, takes attention, so it reduces the chances for any cracks in the bricks. You cast it in a form, better to have it like in a wood form, and then you leave it to dry. And it's better that you flip the bricks so they dry evenly, not to dry quickly from the top and then in the bottom they are still wet. So that's why we flip them in order to dry evenly. Rammed earth is kind of stacked earth, compact way of construction. In Adobe, there's more like air bubbles inside, and that's why the thermal performance of Adobe is better than rammed earth. So you bring the soil, it's more of a dry mix. You add gravel and sand. If the soil is already with this kind of properties, so you don't need to add anything. And you just add a little bit of water, just like to make the clay act as a binding material. Then you stack the layers, and then you ram, and then you add a layer, and then you ram, and it has to be in a formwork, stays in the formwork until it dries. Not like the Adobe, you can just take the formwork immediately, but here in rammed earth, until it becomes a little bit solid, and then you leave it to dry after that. So those techniques are available since ancient times. They are not just like a modern invention. In the southern part of Sweden, we have, like in Skåne, there is plenty of houses constructed with Adobe. In Shibam in Yemen is one of the good examples to talk about Adobe bricks. And they call them the desert Manhattan, because they are high towers in the middle of the desert that managed to survive for centuries, resisting all kind of weather conditions. And please, it also rain there. They get like rainy seasons, they get like storms, so it can survive. Of course, it's dry the majority of the year. It's not like here it rains majority of the year, but still when it rains, it really rains like it's kind of heavy rains, which can actually harm the buildings, but they are constructed in a way that they are safe and waterproof in the way they are constructed. And you can see here, like, yeah, you can build with high ceilings. It is as if you know the structure technique, so there is no problem in that. Another example also from a dry climate in United Arab Emirates, and this is a fort that was restored after a long time of being abandoned, And here you can see like it's possible to use it for modern functions. We were discussing together with Nicholas and how we can have this heating and cooling possibilities with using air pipes or using water pipes. Just be aware of like water leakage. That's the most important thing with earth construction. Other than this, there is no problem whatsoever to equip even traditional and old buildings with old modern techniques, still keeping the characters, keeping the identity of the place, as you can see here. If we look at rammed earth, so this is an example from Morocco, which is one of the traditional techniques there since centuries. You can also find it in the south part of Spain, Portugal. There are also really good examples there, also traditional buildings, and in some places in France as well. In Germany, recently, they also been like it's a booming movement using earthen techniques, especially also with rammed earth. This is not like super new, it's from the 70s, but just to show you like it's the movement started a little bit earlier than many parts of Europe when it comes to start reusing the traditional techniques for contemporary use. Moving a little bit around in Europe, we can see here, this is Martin Rauch's house, and he constructed his house from the digging soil. There was no single material from outside except from some limestone that he used for the erosion lines on the facade. So this is extremely 100% local material. He actually had even more digging soil. He used it to construct his kind of cousin house. So, and it survived up till now. So no doubt that it's possible to do it in a rainy climate. And you can see the roof even is flat roof. It's not like even inclined. So one tip for earth construction, have a good hat and a good boot, and then it survive for a long time. So that's the two important things that you need to take care of. Another example, even like if you want to have it aesthetically appealing with a lot of like interesting decorative elements, this is a cemetery, also by Martin Rauch. Industrializing the whole idea of constructing with rammed earth is not rocket science. There's already a couple of factories in Austria and in Germany and Switzerland now producing rammed earth walls, where they come with cranes, project site, and then you assemble them. And this is actually one good way to use rammed earth in a kind of quick, swift manner. So they come as precast concrete. So you have ready-made walls, and you just like connect them together with metal anchors. Earth also is possible to use as kind of plastering, and that we will see some examples there. And it's also a traditional way of decorating buildings from inside and from outside with clay plastering. Johan, you promised us to tell more about how it started in Sweden with this standardization, and I'm personally looking forward to hear more from you. So for now, we can move to the next room and we can see together the experimental work. I will say a little bit more, and then I come with finalizing this morning. Oh. So welcome here to the place where we stayed for a week, trying and experimenting and working hard to produce these two pieces. And I would like to take the chance to thank again Nicholas and Rasmus for being so dedicated, so passionate about working with these two wall samples. So as I mentioned, we had two techniques to work with, rammed earth and Adobe. So we started with casting Adobe bricks, and here you can see to your right some samples from the bricks. If you look here, you will find the raw ingredients for producing these two elements. If we start with the Adobe bricks, the main raw material is clay, sand, and straw. And we mix them with water, and then we cast them to produce these bricks. They can come, of course, in different sizes, but this is the typical size that we use, which is like the common in the market. We produced also the mortar in order to stick the bricks when we lay the bricks together. So this is also from just clay, sand, and water. The plaster, which is the layer to cover the bricks, like the normal cement plaster use. But here we have only clay, a little bit of sand, and straw. We add a little bit of lime to the plaster and also to the final render in order to make it also water resistant. If we look at the ingredients for the rammed earth, we had sand, we had gravel, and we had coarse sand. I'm sorry, we haven't used, so it's only coarse sand, and we have gravel and clay. And we use different type of clay, this clay powder and this clay that is from Bronshack in Lund, which is the main type of clay that we wanted to test. And also in the Adobe bricks, we only used the clay from Bronshack. For the rammed earth, it's a dry mix. So we mix all these ingredients together, and then we add a little amount of water. And you can see here, this is the outcome. We used several extra material for erosion lines. I will show you in a few seconds on the wall. For example, limestone, and we use also gravel with lime powder mix. So those are the basic ingredients. So imagine you are on a project site. If you want to construct this building we are in, we just dig and see the properties of the material, and then we can decide on the technique based on that. And if we want to try a specific technique, we see how we can make the best use of the local material, and then we can add extra ingredients bring it hopefully from a local nearby place. There are several tests you could use on site in order to make sure this is the right mixture, because you cannot say I have the right proportion and the right ingredients for this technique. If someone tells you this, don't trust it. Always remember the Italian saying, only grandma knows how to make pizza. So the secret is always with the grandma. So you have to test on site, and based on the soil reports you will get from the material, and you have to also make some lab tests if possible, and you can also make some site tests, hand tests, that you can test the different properties of the raw material that you have on site. If you look a little bit on the fridge, you'll find a list of trials, and until we reach the right proportion, and those are the mixtures we kind of stick to and we used along the process. So first we did several mixes, and then we settled on one, and that was the one that we kept on repeating until we managed to finish. When it comes to different tools, I would say the formwork for the Adobe was the main thing, and the formwork for the rammed earth was also a main thing. For the Adobe, you just throw the mix and you take it and you continue. For rammed earth, you have to keep it until the wall is done, and then you take the formwork. Several other tools we used, the normal shovels and mixers and so on. Rammer, that's extremely important for rammed earth, and we use this interesting, this is the manual rammer, super heavy, 20 kilograms, sorry. And there's the electric rammer, which work with pressure. This is a mini rammer, but of course bigger ones, but this is was handy and a quick one to use. Yeah, and later on you can of course explore by yourself and see the different material we used. This is again the clay from Bronshack, we brought for the sake of the experiment, and we have both some gravel and coarse sand. And here's the straw, chopped fine straw, and there is the limestone that we used, and here we have also powder clay, another type of sand, and lime. So they are the exact samples that you can see here. If we look deeper into this rammed earth sample, we tried different like ways of doing it. So you can see it can be rough, it can be smooth. You can use different type of erosion lines. Here, for example, this one with like blue powder. This is just gravel, but mixed with lime. That can be one way if you don't have limestone. So you just can bring gravel and lime powder. Here we used limestone, and here we used chopped limestone. It's better to have it like a little bit smaller than this, but we just adjusted to what we could find. Until here, this is the maybe a little bit of a transition here. That's the dark soil from Bronshaug and Lund, and then the rest are powder clay soil we just bought from provider. Nicholas will tell more about all of this later on. Here also you can see we try to show like how we can have an insulation layer inside the wall, and this can go all the way down. Of course, we are just demonstrating here, and this can be different ways of adding different insulation material. You can even use straw as an insulation. You can use sand. You can use several type of insulation material that is available in the market. Rammed earth can be fur face, so you can plaster it or you can just leave it depending on your taste. For outdoor, of course, it's okay to leave it without any treatment because after a couple of rainy seasons, you will lose few millimeters from the facade, and then the erosion lines will be the one protruding to the outside, as you saw in some of the pictures, especially Martin Rauch house. He used limestone all the way as erosion lines. So that's their purpose. Like you find like slowly the wall is eroding until it reaches a certain limit where this erosion lines are called rain stoppers. So the rain comes and only touch the erosion lines, but they don't touch anymore the wall. So that is one way of keeping it safe and water resistant. Of course, adding extra lime in the mix is a good technique. Some people do stabilized rammed earth by using cement with 5%. I'm personally against this because this destroys the whole idea of using natural material and being biodegradable and go back to nature after the end of life of the building. But it's just to tell you what others normally do, because some people still don't feel safe that just use pure earth. So they add this 5% cement. But please don't do if you do it. It's still safe to just add lime if you want. Or of course depend on the erosion lines. So if for the interior, some people like it soft, so you can adjust the texture and have it soft from inside, or you can plaster it like a normal plastering, also with clay for the interior. Of course, all those colors we added is just like for to show that you can play with different tones if the soil itself is not kind of colorful, so you can add natural oxides, and you can do it in different ways and adjust it to your taste or to the client taste. If we move a little bit to the Adobe one. So here, the typical way of constructing a brick wall. So layering the bricks, and you add mortar. And as I explained, it's a clay mortar with a little bit of like clay, sand in a mix. And you can add lime as well. And here we used plaster, which is straw and clay with a little bit of lime in the mix. And at the end, we did this sanding, and it's called render. So we just sprinkled some water on the mortar, and then we started to do this sanding for the surface. So it's a kind of a texture, and it's also for like protection. To be like if it's exposed outdoor. So this can be one way of treatment. Yes, and that was all about like these two different techniques. I think we can take one or two questions maximum here. Yes.
The recipe on the fridge.
Yes.
And the recipe you said for the water.
Mm-hmm.
I think they refer there. It says that you had lime in the water. You said you had straw in the water.
Straw in the plastering, but not in the mortar. So
are there lime in the mortar?
No, we decided not to add lime in the mortar. It's lime only in the plastering because it's covered anyways, and it's even easy to recycle after when you don't add lime. So you can, if you just take the plaster layer and then you recycle the bricks and the mortar, that's easy for the possibility to reuse it again. Yes.
You said something about how to find the right mix.
Yeah.
But I wonder if I don't know anything about building with clay. So how do I choose the right technique? If I have a site and I have some clay there, how do I find out which technique?
Yeah, that's a good.
Suitable?
Yeah, that's a very good question. Do you remember the wheel?
Yes.
Yeah, so it shows the different techniques based on the different soil components. So if you have this soil with more sand, for example, or more gravel, then rammed earth can be the best technique. If it's just pure clay with a little bit of sand, and then adobe can be the best technique. So it really depends on the properties. So if you look at the soil analysis test, you determine the ingredients, like, okay, this is high percentage of sand or high percentage of clay or silt, and then you can decide accordingly. So the soil properties is the one helping you to decide on the technique.
Where do I find that?
There are like not standards, but like guidelines for like what could be the right material for the right technique. Any other? Yeah, sure.
About sand, because you said that you added sand,
Yeah.
and with concrete, we're always talking about that sand is a problem. We're taking sand from very far away, and we're lacking sand, and it has to have very special. It has to be a very special type of sand.
Yes.
And do we have the same problem here, or can we just take any type of sand?
Normally, the idea is you take the soil from the site. So if the soil on site had a high percentage of sand, then this is a sign that, okay, this is the technique that you could use, for example, rammed earth, or there are also types of bricks that can take more sand compared to clay, like compressed bricks, for example. So of course, it's not advised to take sand from anywhere. Because there are also places where the sand is very pure and it's kind of a place where it should be protected. So you shouldn't like dig and just take sand and let's use it. I know like in some places they actually buy sand just to lay on their beaches and to enjoy like some nice feeling. So that's also not an environmentally friendly like way of doing it. So we need to be conscious about like the material use. So if on site the material gives you this potential to use it with different type of earth technique, then you go for it without bringing extra material from outside. And then by this way you protect nature, and without if you don't add any industrial ingredients like cement and others, it's possible to bring back this material to the ground when the building is like the lifetime expectancy is over, and then you have to tear it down. So it goes back to nature the same way as it started. So by this way, you bring it back again to the ground.
Okay. So adding sand was more for the experiment, and if you're on site,
we just used what we have.
It's an excellent question, because after you got the question about we have to excavate clay, not the problem to excavate things, but it's actually the sand is the big problem, not the clay. And sand, you use sand in cement as well. So In Germany, they're looking at using other ballast instead. So like crushed bricks instead, or something else to reduce the amount of sand. And traditionally in Sweden, at least, we haven't used sand. We have more fiber instead. But in modern, when we want a thin plaster, for instance, then it's easier to use the sand, and it's easier to mix it with sand. So, as you said, it's a lot of problem with use the excavation of sand is connected a lot with you can Google sand mafia and the UN sand report from 2022. That's really interesting as well. So yeah, sand's a big problem.
And I would say for any natural resource, we shouldn't overuse any material, even we have abundance from it. But we should use it in a careful and conscious way. Yes.
May I add to it?
Sure.
It was you mentioned that circle we saw in there, and there are some techniques which are very light in sand. You can basically just have clay. Then you take wood chips, you take straw, and you build a lightweight building. So I mean, if you don't have sand, don't build with it. Find what else is there. Are there lumber? Are there straw? And you can get another type of building which may be more suited.
Exactly. So look around in the environment around. This is the one good tip, because it will inspire you with what will be the material to use and what will be the technique to use.
That actually brings values to the building. It's belonging to the place. If you use material from the place, then yeah, the extra thing you can sell in for the customer. It's a good feeling for yourself.
Exactly. So if you're close to farmland, then natural fibers can be one good resource because it's already agriculture waste. If you're close to like a place where there is stone, or you're close to the forest, use wood. So it depends on where you are. So you decide on the material accordingly. So maybe it's good time to go back and finalize. Thank you. How we can move forward from this, because it's not only about being passionate about using the material. Yeah, so what is next is always the question, how we can move forward. Being passionate about a material is not enough. We need also to see the feasibility and possibility in order to make it possible to have it as a mainstream. It's still limited experimental work. And I must say, like, what HSB is doing now is a kind of a daring do thing, and to try and to experiment and to see the possibility and how to use this for contemporary practice. But also we cannot depend only on just like a traditional way of construction. We need to use technology for like our site. We are like in a luxurious situation now with our contemporary advances in technology. We have machines and we have labs and we have software that can help us make a lot of sophisticated calculation that wasn't possible in old times. In old times, they could afford trials and errors. They have the time and they have the opportunity, but now time equals money. We cannot keep on just making mistakes. We need to use, of course, mistakes are good because we learn, but how to reduce the time figuring out the right way of doing it, we need to use technology in order to facilitate the process in order to make, again, clay as a mainstream in construction. So this is an experiment in Italy in using robotics and digital fabrication. It's also an experimental pilot project. This is a movie. Yeah, I think it's working now, right? Yeah, so you can see here, this is kind of a digital fabrication using robotics to cast earth as kind of liquid earth, and you can build with it this kind of layer. So it's similar to the cast earth technique and COP somehow. So this is what we aim for now. It's a lot of experiments going on in using all this modern technology in order to facilitate and to make it a quick process. There are still a lot of challenges. Clay is like we treat it many times as it's concrete. So when they use this digital fabrication and casting, of course, clay got stuck in the nozzles where they use to cast earth. So it's not as it is the same performance as cement. So we need to adjust the way of thinking towards using clay compared to using cement. So this is again a shift that we need to be prepared for. As the shift we started to have moving from using natural material to industrial material, we need to come back again with this shift to understand how we can use natural material, but in a more advanced way. So this is a hope that we are waiting for some good results from the ongoing experimental work in different parts of the world. Because if not now, then when? We have to like wake up from this, yeah, I would say bad dream we had now in using all this toxic, heavy environmental burden material on the environment. So let us hope that soon we will be able to reach a level that we could say, yes, tomorrow we can construct at least residential buildings using earth material or other type of natural material that can be possibly used, like straw, like reeds, and many more. So for now, I would like to say thank you so much for your patience and for being here listening to this talk. And I think we have 5 minutes for a couple of questions, if you have like general ones or specific ones concerning this experimental work. So feel free.
Yeah, I would like to know your opinion about Hassan Fatih and his importance for making to popularize this method, or as a general architect.
Yeah. I followed personally his school. I'm from Egypt, and he is like a popular figure. So he was kind of a pioneer for his time. Like early on, he was talking about how we can use earth as a material for contemporary use. People didn't listen to him, and they looked at his way as you are taking us back in history. It's sign of backwardness, or it's a peasant culture. It's only poor people and farmers live in clay houses, and this we still hear in many places. Every time we talk about clay, and they said like, it's hard for me like to keep saying this, but it's true. Like if we are in Europe and we are talking about clay, you say like, they look at us like, but we are not in Africa. We are not working with a developing project or a development project. But why clay is associated only with like being poor? It's a very rich material. It's actually the opposite. I would say concrete is a poor material. It's like environmentally poor compared to what we perceive as clay as an environmentally rich, and straw and many more stone and many more like natural material. So imagine like replacing using wood with using earth, how this would even save also the environment. All this kind of overusing wood nowadays, it's a kind of a greenwashing, to be honest, if you ask about my opinion, compared to using, we have to face it. It's just labeling again, using wood as an eco-friendly material. So definitely, Hassan Fathy made like a huge contribution when it comes to using.
And it's well known in your field, let's say. And among the students abroad.
Exactly. And his books are still like really handbooks for to know how we can do also like kind of climate friendly designs. Yeah. So without compromising statics, without compromising like comfort. Like using earth also, like we wouldn't have time to talk about like how it provides comfort all year round, coping with extreme heat and extreme cold. So the clay itself as a material had this kind of adjustment to the temperature. Let alone it's a breathable material. We live in envelopes that are kind of imagine like you do this to yourself all the time, like you're covering your nose and mouth and you suffocate. So this is what we do now with all this industrial way of constructing our buildings, very airtight, super insulated, and we lose this natural breathing feeling when you live in an envelope that is constructed with natural material. So that will be my frank opinion concerning this. So we will take last two, one and then two.
Yeah, I wondered because now you mentioned this problem of the image, and I hear this so much that like in many countries it's always the material of the poor, and we always replace it with concrete, and concrete has a huge lobby. So how do you, besides all these experiments, and also work with like lobbying for clay, and do you think it could be actually a chance now when we talk a lot about circular economy that there might be a chance when we see other kind of economic systems to actually make clay more attractive, because we cannot gain a lot of money with the material itself if we have it on place different to concrete.
Yes, it's always perceived as a material that is not tempting for all those, I call them the tycoons in the field. So we face a tsunami of resistance from cement factories, from brick factories, from all like those big investors. They have all this kind of business and they cannot be out of business overnight. So of course they will be the first to stand in front of all these movements strongly, I have to say. So that's why it's very slow movement towards using natural materials and cost-efficient materials. But actually, if we look at it from like I'm not like person who is expert in economy, but a basic thing, there's a need and demand, right? So if there's a need, you have to offer something to cope with this demand. So if investors, if developers, they insist on having this material, the market will respond and will offer this. So we still have a problem with supply chain, for example. If we want to use this kind of natural material, you don't have a supply chain for it. But if you insist on using it, if the codes support you, if the political will supports you, then the whole industry will follow. And the building sector is responsible. We all know this fact, and we shouldn't keep on saying that we are the most responsible sector when it comes to emissions and pollution and environmental burdens. So we have to be the first to lead. towards a positive. The last question.
Yeah, my question was kind of similar. I was going to ask what is the most common argument to not use earth in buildings and such?
Still, up till now, we cannot build a stadium using earth, but it's not possible if we had the will to do it, like skyscrapers or like, yeah, all these different, it can be a kind of hybrid maybe, but not like purely from clay. So there are still limitations in using the material because of the limitation in technology. It's not because of the limitation of the material. It's because of the limitation of investing in trying and developing and making it possible. It's the way we think, it's the way we design, it's the way we construct. So there could be still an argument that they will tell you tomorrow, tell me how I can construct 50 floors, a building with clay. Yeah, hybrid maybe, can like be the filling with the earth, but the main skeleton or structure can be with other material. But that's possible to maybe in the future, but not now. So there could be some hinders. But other than this, one big hinder is still like with the building code and building regulations. Johan will say more about this. We don't have still, like if I go now and ask for a building permit, they will say like, how is that possible? We don't have it in the code. Like they have the books. Clay is not material listed. Sorry, I cannot approve it. No controller would be daring, for example, to sign if you know if something is not complying with the standards. That can be still another hinder. Yeah, supply chain, we can go around it a little bit. Yeah, we can find ways and finding like the proper way of resourcing, especially if you use the material from the ground. The technical know-how is not complicated. Nicholas will share more about this and how it's easy and quick to learn. It's not rocket science. It's not impossible. It's really in a few hours you can learn the technique. With a good like supervision, you can go far. So those are some of the arguments. Some maybe can be also directed towards like social perception, as we were talking, culture norms in the society and how people perceive it. So maybe we can end now, so we can give the time for the coming speakers. And thank you so much again for your time.